Hey guys, I've got a problem for us here, and it's a mass tied to the top of a pole swinging in a horizontal circle. Okay, so this is just like tetherball. We've got a ball tied to the top of a pole and it's just swinging around in a circle. So I tell you a few things about the situation. The rope in particular is 9 meters long. Okay, the angle between the rope and the pole is 47.9 degrees, and I also tell you the tension in the rope is 5.3 newtons. And that's all I tell you, okay? So I'm gonna ask you a series of questions about this situation, and hopefully it's gonna allow you to completely understand the physics behind a situation like this. So the first question I wanna ask is, what is the radius of this circular path? So you can see here the path is circular, so its radius is gonna look like this, right? I wanna know, what is that radius? And if you notice here, when I draw this radius, it sort of makes a right triangle with the pole and the rope. And you'll notice this is a recurring theme in general physics. They like to give you situations where you can make right triangles and then use trigonometry to find unknown side lengths or angles. So that's exactly what we have to do here. So I redrew this right triangle right here, and you can see the hypotenuse, or the diagonal, is the 9 meter long rope. This angle up here is known, it's 47.9 degrees. And we know it's a right triangle, so I went ahead and wrote in the right triangle symbol there, that little square. And we want to know this side, right? The radius. And I just wrote in this bubble over here some reminders from basic trigonometry. And the mnemonic I want you to remember is SOHCAHTOA. And I tell you what all those letters stand for here. It's sine, cosine, and tangent. And then O is opposite, A is adjacent, and H is the hypotenuse. And what you need to know is that the functions of sine, cosine, and tangent of a given angle are: sine is opposite over hypotenuse, that's why it's SO, OH. Cosine is adjacent over hypotenuse, or CAH, CAH. And tangent is opposite over adjacent, or TOA. So that's how you remember that. So in this situation, we have the hypotenuse and this angle, and we want the opposite side from the angle. That's how you define opposite, adjacent, and hypotenuse. So from this angle, the opposite side is what we want. This would be the adjacent side. We're not worried about this. We want the opposite side. So which trigonometric function includes both the hypotenuse and the opposite side? So OH, so that's OH. So we're gonna do sine of 47.9 degrees. We know equals the opposite side, which is what we want, R, over the hypotenuse, 9. So this is the key here to finding the radius. Then we simply multiply both sides by 9, and that'll cancel this 9 out here, and we end up with 9 times sine of 47.9 degrees is equal to our radius. Type that into your calculator, and you get 6.68 meters. So that means the radius here is 6.68 meters. Okay, the next question I'd like to ask here is, what is the mass? So in other words, what is this mass right here? Well, the way that you do this is you set up what's called a free body diagram for the mass. And what that means is you're essentially diagramming all of the forces acting on this mass. Well, to start off, we know gravity is always going to be pulling straight down with mg, mass times the gravitational acceleration. And in this case, we know a tension is pulling up in this direction at 5.3 newtons. And we know whenever we have a diagonal vector, we can split that up into its x and y components, tension in the x direction and tension in the y direction, if we need to. And we also know that whenever we're moving in a circle, we're going to have centripetal force or radial force pulling us directly out of the circle, right? With m times velocity squared over r, or m times centripetal acceleration. So in this case, we know that since the mass is not moving up or down, it's just moving at the same level in a horizontal circle, we know that these two forces must have canceled each other out perfectly, right? Because there's no movement or acceleration in that plane. So Ty, or the y component of this tension, must equal the gravitational force, or mg. So if I can just set those equal to each other, then hopefully I can solve for this mass here and get my mass. And that's exactly what I did. So in order to get the y component of the tension, what you have to do is set up a right triangle for the tension. So I drew that down here. So I know my hypotenuse is 5.3 newtons. That's the diagonal here. And my ty, or the y component of the tension, is this side right here, or you can also think about it being right here, as in the mass is being pulled in this direction, and there's a y component and an x component of that tension. So to solve for this side, we know that this is the adjacent side to this known angle here, 47.9 degrees, and we also have the hypotenuse. So whenever you have the adjacent side and the hypotenuse, we know we're dealing with a cosine function. And we know cosine of some angle is equal to the adjacent side over the hypotenuse. So that's what I did. I said cosine of this angle is equal to adjacent ty, tension in the y component, over the hypotenuse, 5.3. And then I wanted ty by itself, right? Because ultimately I want to set ty equal to mg. So I wanted ty, so I multiplied both sides by 5.3 to cancel this out. And I got ty is equal to this right here. So then I was able to set that equal to mg. I know g is 9.8. And then to get m by itself, which is what I want to ultimately solve for, I divided both sides by 9.8, and I was able to cross that out. And then I was left with m equals this. And once you type that into your calculator, you'll get mass equals 0.363 kilograms. Okay, the next question I'd like to ask is, what is the velocity of the mass? In other words, how fast is this mass moving around in this horizontal circle? Well, again, we have to take advantage of our free body diagram here. And we notice that velocity appears in this term here, the centripetal force, mass times velocity squared over radius. And we know that that must cancel out the x component of the tension. Since the mass is not moving closer and further away from the pole, it keeps its distance from the pole. Thus we know the forces here are fixing it in this position, so they must be equal. So that's the key, you set these equal to each other. Now the trick is finding the x component of the tension, and this is extremely similar to how we found the y component of the tension for the last question. We just set up our right triangle as we did before, and now we're solving for this side, right? So what we say is we want the opposite side of this angle, and we have the hypotenuse. So opposite and hypotenuse, that's so sine of 47.9 degrees is equal to the opposite side, tx, over the hypotenuse, 5.3. So tx is equal to 5.3 times sine of 47.9 degrees. So that is what we'll put in for tx. So ultimately what we want is this velocity here, right? So you have to do a little bit of algebra to get this velocity by itself. So first what I did is I divided both sides by mass, and that left me with v squared over r equals tx over m. Then I multiplied by radius to get the radius out of the denominator. And then I was left with v squared equals tx over m times r. Then to get rid of this square, I took the square root of both sides. And finally, I was left with velocity equals the square root of the x component of the tension over mass times the radius. And I simply plugged in my numbers for everything. So I found the x component of the tension here. So I put that in for tx over the mass, which we had previously found, 0.363 kilograms, and then the radius, which we had also previously found, was 6.68 meters. And once you type that all into a calculator, you will find that this mass is moving 8.51 meters per second in this circle. All right, the last question about this problem I want to ask is, how long does it take this mass to complete one full circle? So the basic idea here that you want to use is that speed equals distance over time. You know, we're all familiar with that, and the fancy physics version of that is that velocity equals delta x over time. So we have velocity, right? We just found that, 8.51 meters per second. But we need to know delta x. In other words, how far is the distance of one complete circle? Well, we know the distance around a circle is just its circumference, right? And circumference we know is 2 pi times radius. So our delta x is just going to be 2 pi times our radius. We already had found our radius, 6.68 meters, so we simply plug that in, and we find that one complete circle is 41.97 meters around. Now we have a delta x, and we can simply solve for t. So I multiplied both sides by t here, and I got 8.51 t equals 41.97. Then I divided both sides by 8.51 to get t by itself, and I got my final answer of t equals 4.93 seconds. That is the time it takes for this mass to make one full rotation. So I really hope this video helped you guys out. If you have any questions or you're interested in tutoring, please contact me at facebook.com/denovotutoring, and I'll see you guys in the next video. Thanks a lot.